learning today about harmonic motion. So first of all, what is harmonic motion? Harmonic motion is a type of motion that we can use to model objects that vibrate, oscillate, rotate, move in a wave-like motion that represent a circular motion that is repetitive. So it's going to continue to go around and around this circular type of motion, which means it's also going to be the term periodic. So we've used that word already as well as periodic. And these are represented by these sinusoids, which we know are sine and cosine functions. So there you see some examples of when we can use these. We can use them for measuring, modeling voltage, predicting the tides, and looking at the waves when the tide comes in versus when the tide comes out, and how that affects the height of the waves. On other things, a spring stretching and bouncing back and forth and oscillating. Okay, so let's go ahead and take a look at an example. Oh, sorry, not an example yet. We have vocabulary. So just some vocabulary. A sinusoid, as I said, is going to be either a sine or cosine function. We know the standard form for each of these formulas already. We know that that standard form is the two forms that you see right there. Y equals a sine of b quantity x minus c plus d, or y equals a cosine b quantity of x minus c plus d. And then we have amplitude. So amplitude, we know, is the distance above or below the center. It's half the range. We also know that the amplitude can be represented by the absolute value of a. Next, we have the period. We already know about the period. The period formula is absolute value of 2 pi over b. And it's representing the unit of time per one cycle. Okay. And last, we have the frequency. The frequency is the reciprocal of the period. So we can see that the formula is b divided by 2 pi. And instead of the period being unit of time per one cycle, we're looking at number of cycles per one unit of time. All right, so now let's take a look at an example. So here we have the Ferris wheel problem. So thinking about this problem, it tells us we have a person seated on a Ferris wheel, and in this class, we are always going to have a Ferris wheel move in the counterclockwise direction. Okay, so we're always going to be moving in a counterclockwise direction. So counterclockwise for this class. All right, so you guys can just read that paragraph to yourselves. And just note some of the important information. Maybe you want to start drawing it on your diagram. And what we can see is we see that we are asked to write an equation. So we want to find a graph. We want to find and graph. So we're going to write a function, and we're going to graph the function to represent. And here we want to make sure that we pay attention to what we are supposed to be graphing. We're graphing the person's height above the ground. Okay, so height above the ground at any given time. So our x-axis is going to be the time, and our y-axis is going to be the height above the ground. All right, and so we want to make sure that we always label that on our in our information. And so this is going to be our x values. And then the person's height above the ground here, this is going to be our y value. All right. So moving on, and let's go ahead and put this together. All right. So I'm going to label a few things on my diagram here to kind of help me see what's happening. So I know that the radius of the Ferris wheel is 100 feet. And it also tells me that the person is starting at the center and moving up at the beginning. So here is my little person in my little Ferris wheel cart. Just kind of draw it like the diagram there. Okay, so we're starting there and we're moving up. It also tells me that the height above the ground is 105 feet. So this distance here from the ground to the center, that distance right there is 105 feet. And I wrote in the radius, but I didn't label it. That's 100 feet. Okay, so I want to think about what's the maximum distance above the ground that we're going to be moving. And that maximum distance above the ground here, it's going to go all the way up to the top. If I find that whole length, this green segment, well, that's going to be that 105 feet plus the 100. So that's going to be 205 feet is going to be the max that I reach above the ground. Okay. All right, so let's go ahead and start putting this together. So on my graph here, I'm going to label my axes so that I have that labeled. My x-axis is time t, and the time that we're given is in seconds. So I'm going to put the units on there as well. Always make sure you label with units. The y-axis is going to be d, I'm going to call it, and this is going to represent distance above the ground. And we'll put that in units of feet. Okay. So we know that the person, the furthest distance above the ground is going to be 205. And so when we're making these, you don't have to put them on graph paper. You can just draw them and just make sure that you're labeling all the points. So the furthest the person's going to go is 205 feet above the ground. The lowest the person is going to go, some might think the lowest is going to be 0, but the lowest the person is going to go is actually going to be this point right here. And so that green or that purple there is going to be 5 feet above the ground. So we take the 105 to the center, subtract the radius to get the person's lowest point is going to be 5 feet above the ground. So my lowest point here is going to be 5 feet. So put a 5 right there. The person is starting then in the middle. So if I look halfway between these two, this person is starting at that red spot there. And so this value, the distance above the ground for this person right here, is here all the way down to the bottom. Many people get confused and they want to label it as 100, but it's actually 105, right? That's from the center to the ground. So we're starting at 105 feet above the ground. All right, so now let's go ahead and look at what function are we going to have. So if I start here at 105 feet above the ground, I'm rotating in a counterclockwise direction. I'm going to get further away from the ground to my maximum of 205. I'm going to get closer to the ground. I'm going to get to the lowest point here of 5. And then I'm going to go back to where I started. And so when I think about that, I can see which type of function I'm going to be writing. I'm going to be writing a sine function. All right, so my sine function. Well, I use d for my y value, so I'm going to write it as a function d of t. So d of t is going to equal a sine of b, quantity of x minus c plus d. I'll put a little asterisk by this d because it's not the same d. And now we want to find the a, b, c, and d values that are going to represent this function. Okay, so one piece of information that's important in here is the where it says that we have one rotation every 20 seconds. So one rotation every 20 seconds, that indicates to us a method for finding the period. And so we can say then that the period, which we know is the absolute value of 2 pi over b, we know since we have one rotation per 20 seconds, that every rotation is going to repeat. So one rotation is one period. So the period is 20 seconds. So I'm going to plug in 20 equals the absolute value of 2 pi over b. And I'm always going to use a positive b value because that just makes it a little bit easier. And I solve this and I get b is equal to pi over 10. So now I have my b value in my function, so I can plug that in, pi over 10. And so I know the rest of it. Sorry, not the rest of it. I know that I'm going to have sine, so I'm going to have d of t equals, I still need to find my a value, and I still need to see if I have a c value, and then my d value. All right, so let's go to the a value. Well, the a value, I can use my graph, and I can see here on my graph what the amplitude, or the a value, is by representing this distance here. From the center to the maximum, that's going to represent my a value. So I can see there, that's where I'm going to put my a value. And based on that, I can see that my a value is going to be 100. So let me grab a color. I'll put that in purple. So my, oops, highlighter in my pen. So if I go ahead, that's going to be, my A value is going to be 100. Then I also need to determine if the A value is going to be positive or if it's going to be negative. Sorry about that. And since my graph goes up first, I know my A value is going to be positive. Okay. All right. So that's the 100 right there. And then next, I want to find, sorry, I'm not sure why it keeps switching on me. I want to find the C and the D values. Well, the C value is my phase shift, and I can see here that I don't have a phase shift. I start in the horizontal location where I would if I were to have parent function, so x minus 0 for my C value. And then for the D value is my vertical shift. Why does it keep doing that? And my vertical shift here, I see where this midline is. Well, this midline I can see right there. And so that midline is shifted up 105. And since it's shifted up 105, that means that my D is 105. Common error is to put D as 100 here. Okay. And I'm not sure why my computer keeps doing this, but oh well, we'll keep going back. So that's plus 105. And so there I have my function. Okay. All right, so with that function then, you don't have to put the 0 in there, and so you can just rewrite it, although my computer is probably going to be annoyed with me. And so I can write d of t is equal to 100 sine of pi over 10 times x plus 105. And then that's going to be the equation that I'm writing. And I've written my equation. All right, so we'll just do it from here for the rest of it. So I've written my equation here, and now what I want to do is I want to label my points. Okay, so this here represents for one period. We know that one period is 20 seconds. And so putting here on 20 seconds, let me just go ahead and draw. So here we know that this is 20 seconds. Okay. And then halfway of the period then would have to be 10 seconds. Half of the half would have to be 5 seconds. Half of the second half would have to be 15 seconds. So we're going to label one period of points. So here I have this point is going to be at 20, 105. And then my low point here is at 15, 5. My middle point here is at 10, 105. My maximum point is at 5, 105. And then my first point is at 0, 105. And so you just have to label one period of points. You don't need to label anything else. But it does ask us to graph this for one period. And, or sorry, not for one period, but it asks us to graph this for a 1-minute ride. So we're going to do for a 1-minute ride. Since this is 20 seconds, a 1-minute ride would be 60 seconds. So that's going to be 3 periods. And so I am going to continue to make this graph for 2 more periods. And so I know that that's going to be going in increments of 5. So if I make kind of 25, 30, 35, 40, 45, 50, 55, 60 here. And then I can start by just putting my points on there. And so my next point is going to go high. So at 25, I'm high. And then at 30, I'm in the middle again. 35, I'm low. 40, I'm in the middle. 45, I'm high. 50 in the middle. 55 low. And 60 back to the middle. And then you're just going to go ahead and connect these. You don't need to label those last points. All you need to do is connect them. All right. We're going to go ahead and just stop this video right here, and I will do the second example on another video.